Okay, we're going to see how to use the differentiation rules in order to calculate derivatives. First, we need to understand the notation that we use for derivatives. We can work, whenever we want to mention or call a derivative, we can use the prime notation, which was developed by either Newton or Lagrange. In this notation, if we work with this thing, we're going to call that f prime. This thing will be called prime of x. Or we can say y prime. Both of them are interchangeable. We can also use the differential notation made by Gottfried Leibniz, where we say d on dx of f of x, or dy on dx. Both of them are interchangeable. We're going to use differentiation rules, which are formulas and theorems that are going to help us make calculations easier. So, which are those formulas or theorems that we need to understand? Well, there are several differentiation rules. We're just going to work with 8 in this video. Well, 7. Number 1, derivative of a constant. That letter A in this description means a number. Okay, a specific number. It could be 5, it could be 4, it could be minus 10. It doesn't matter the number. Okay, the derivative, or d on dx, of any number will give you 0. That's the first rule. The derivative of letter x is going to give you 1. The derivative of x but with any other number, any sort of number, like imagine that we have 3x in here, well, that will give you 3 in this case. If it's 4x, then that will give you 4. That's what this rule is telling you. The derivative of a constant multiplied by x, or a linear term basically, would be the coefficient of that linear term. The derivative of a sum or a difference. Well, if you have two things that are being added or subtracted, the derivative will be very simple. You just find the derivative of each one of them. So derivative of u, okay, which is u prime, and then you add or subtract depending on the signs with the derivative of the other one. In other words, it means you use distributive differentiation. The derivative of a power, okay, if you have anything like, let's say 5x squared, okay, you have a number, you have x, and you have an exponent, okay. How do you find the derivative of that? Very simple. You multiply, okay, the coefficient with the exponent. That's why I say a times n. You copy the letter and you subtract 1 to the original exponent. So I subtract 1 to 2 in this case, it will be 1. Well, that's invisible 1. If this 2 would have been 8, for example, then 5 times 8, 40x, and I subtract 1 to the 8 will be 7. So that's the process to find the derivative of a power. Each one of them will explain, basically each one of these rules explains you what to do in every single case. What will be the derivative of an exponential? An exponential in this case being using the Euler's number with as a base. So in this case, if you have e raised to any sort of linear term, what will be the derivative? So for example, if I have e raised to a single x, the derivative would be e raised to the same x. Okay. Now what happens if I have a number in there like e raised to 7x? Well, in that case, the derivative will be 7e raised to 7x. So you just add, you just put the number before the e, and that's it. The number that's on the exponent, you put it before letter e. The derivative of a product. What happens if you have two things that are being multiplied and things that you cannot simplify? So in that case, what we're going to do is we're going to take turns. Remember that the prime notation means derivative. So if I have u, that will be just any sort of function. But if I have u prime, that is finding the derivative of that. Okay. So how do I find the derivative of a product? Well, you take turns. You find the derivative of the first one, and then you just copy the second one. You don't find the derivative of the second one. You just copy it. Then you add, and this time you don't find the derivative of the first one. You just copy it. But this time you also find the derivative of the second one. So it takes turns. First you find the derivative of the first one, and then you find the derivative of the second one. The other one you also, you just copy it. I'll not explain derivative of a quotient. We're not going to use it in this video. So let's try to apply those rules to these exercises. Let's calculate the derivative of the following functions. Okay, I have a function, fx equals minus 3. Well, remember, this is an a, right? So the derivative of a constant will be 0. So f prime of x would be 0 because that's a number. Derivative of a number is 0. And that's it. Next one. G of x equals x. Well, derivative of x is 1. So g prime of x would be 1. And that's it. I'm using rule number 1 for this one. I'm using rule number 2 for this one. Now let's see the next one. Y equals 2x. Well, I'm going to use rule number 3 for this one. The derivative of a linear term is the coefficient of that linear term. So y prime equals, in this case, 2. The x disappears. That will be rule number 3. Then rule number 4. Well, remember that when we find the derivative of things that are being added, we just need to find the derivative of both things. Yeah? That will be rule number 4. Find the derivatives individually. So f prime of x, in this case, will be equal to, well, derivative of this, rule number 3, is just the number. And then derivative of this, remember, rule number 1, is 0. Since the derivative of 4 is 0, I'm not going to put anything because it's 0. So this will be the answer for this 4 exercises. Let's do some more. So, derivative of 4x raised to the power of 6. Well, I'm going to use a derivative of a power rule. G prime in this case of x will be, well, you multiply 4 times 6 and then you subtract 1 to 6. That's what the rule tells you to do. So 4 times 6, 24. X raised to the power of 5. You subtract 1 to 6. And that's it. That's all you have to do. Let's find the next one. Y equals e raised to 5x. Well, derivative of an exponential is just y prime equals, well, I copy the coefficient of the exponent, 5, and then I just copy this thing identically, e raised to 5x, and that's it. That's all I have to do. The next one, f of x equals e raised to x. Well, same thing. I use the same rule again. F prime of x equals, okay, I copy the invisible one, so since it's invisible, I'm not going to put anything, and then I just copy this thing again, and that's it. Let's see this one now. I have 3 things. They're being added and subtracted, so the rule of sum or difference in this case tells me that I need to find individually each one of them, okay, each one of the derivatives. So y prime in this case, or the derivative of y, would be, well, derivative of this will be 6x, right? I multiply this with the exponent and I subtract 1 to this. Then the next one, well, since this is a linear term, derivative of a linear term is just the coefficient. The derivative will be just minus 4, the x disappears. And this is a number or a constant. Derivative of a constant is 0, so I'm not going to put anything. And that will be it. Let's see some more examples. So, how do we find the derivative of this fraction? When you have fractions like that one, I would advise you to do the following. Do not find the derivative yet. Just rearrange this thing. Move this thing up to the numerator. By doing so, the exponent will turn negative. So this thing is the same as 4x raised to the power of minus 2. Okay? Change it from a fraction to a normal power. That way we can use the rule of the difference of a power. We just multiply 4 times minus 2 and we subtract 1 to minus 2, which would give us minus 3, right? So the derivative of this, y prime, would be minus 8x raised to the power of minus 3. Now, we don't like having these sorts of things. We want an answer like this one. So now we're going to move this thing down again. So we're doing that in the next step. It will be minus 8 over x raised to, now the exponent is going to be positive since I move it back. That will be the derivative. That's it. The next one. Well, we have 2 things that are being multiplied in here. So we're going to use the rule of the derivative of a product remember, we need to find the derivative of the first one. This one we just copy it. And then we're just going to copy this one, and we're going to find the derivative of this one. Okay? There's an order for these things. That's what the rule tells us. So let's do that. F prime of x equals derivative of the first one will be 2 times 7, and you subtract 1 to the 7. So it will be 14x raised to 6. And the second one, the v, you just copy it, right? So e raised to 2x plus. Now we're going to do the opposite thing. We copy the first one, and we'll find the derivative of the second one. So 2x raised to 7, I'm just going to copy it, 2x raised to 7. And then I'm going to find the derivative of this. Derivative of this will be 2e raised to 2x. Notice that we can multiply this 2 with this 2. So let's do that. F prime of x equals 14x raised to the power of 6 e raised to the power of 2x plus 2 times 2, 4x raised to 7 e raised to the power of 2x. Now, these are not like terms because this one and this one are not the same. So I cannot simplify this. I cannot add 14 plus 4 because they're not like terms. So that will be the end of the exercise. That will be the derivative that we're looking for. And let's go with this to other examples now. Same as in exercise 9, we're going to rewrite the function because we don't have a rule for radicals, which means we need to transform the radical into an exponent. So gx, okay, this one, will still be 8 square root of x. So I'm going to write 8, but instead of square root, I'm going to write the square root of x in the exponential form. The exponential form of this will be x raised to 1/2. This and this are the same thing. But I decide to write it this way because now that I have an exponent, I can easily use the rule of powers. I multiply 8 times 1/2 and I subtract 1 to this. So let's do that. Let's find the derivative. G prime of x, or the derivative of g, would be 8 times 1/2, that would be 4, x to the power of, if I subtract 1 to this, it will give me negative 1/2. Now remember that when you have a negative exponent, you need to move this down, right, under a line. So we're going to do that. G prime of x is still this thing. I'm just going to rewrite it. It will be 4 over x raised to 1/2. Now we don't like fractions as exponents, so we're going to go back to write it as a radical. So g prime of x will be equal to 4 over square root of x. Remember that x raised to 1/2 and square root of x are the same thing. So this would be the answer for the derivative of 8 square root of x. Now let's find the derivative of this one. hx equals 5 square root of x. So we need to rewrite it, remember. So hx equals 5x to 1/2. And then, well, now we can find the derivative. H prime of x will be equal to 5 times 1/2 will be 2.5. But I'm going to decide to write it as a fraction because in the end I need to write it as a fraction. And I don't want to mix fractions with decimals. So 5 times 1/2, I'll leave it as 5 over 2. I subtract 1 to this, so that will give me x raised to negative 1/2. Now remember that when you have a negative exponent, that means that the entire power needs to be moved, in this case, down to the denominator position. So h prime of x, I need to rewrite it, will be 5 over, remember that you have a 2 there, so I'll put the 2, but now this one will be a companion for number 2, so it will be 2x raised to negative 1/2. No, to positive 1/2, because you moved the 1/2 down. Now, we don't like this thing, so we need to write it as a radical. So I'll rewrite it again. H prime of x equals 5 over 2 square root of x. And that will be the answer for the derivative of 5 square root of x. Okay? All of these examples allow you to understand this basic differentiation rules.